Hello everyone. Today I am starting a very important topic, Laplace and inverse Laplace transform. And this topic is very useful in engineering field and also in mathematics and physics field. So first understand what is Laplace and what is inverse Laplace transform. Before that, let me introduce myself. I am Dibyendu and this is my channel Math Cyberspace. So let's start. So first question is, what is Laplace or what is Laplace transform? Actually, Laplace transform, this is one type of improper integral. Okay. Here, suppose we are given a function of t. Okay. You are given a function of t. You are given a function of t. Let's say f of t. Okay. This is function of t. Now we have to convert this function of t to a function of s. Okay, let's say this t means function of time. Okay, and let's say this s means displacement. And you have solved many problems in physics where you can convert a problem where the time is given and you have to find out displacement. Okay, so here is the use of Laplace transform. So function of time or f of t that will be given and you have to find out f of s, and this is, we can denote in this form, that Laplace of f of t, this is equals to f of s. Okay, now how to convert this? I have told you that this is one type of improper integral. So what is the improper integral? Laplace of f of t, this is equals to integration 0 to infinity e to the power minus st ft dt. This is our Laplace definition of Laplace transform. Okay, so Laplace transform, this is one type of improper integral, and here the improper integration is integration 0 to infinity e to the power minus st ft dt. Okay, similarly in inverse Laplace transform, the function of s will be given. Okay, and you have to find out function of t. This is the process for inverse Laplace transform. In this lecture, we will learn some basic formulas of Laplace transform. There are total 9 basic formulas. Actually, there are total 19 formulas in Laplace and inverse Laplace transform. And out of these 19 formulas, 9 formulas are totally basic. Okay. So first, let's understand the basic 9 formulas. First of all, let me tell you the 9 formulas. Okay. Then I will prove some specific formulas. So first, here I have we will learn Laplace transform and inverse Laplace transform together. Okay. First, here given Laplace transform and inverse Laplace transform. Just a minute. Here we have two columns, Laplace transform and inverse Laplace transform. So in left hand side, I will write the formulas of Laplace transform, and right hand side inverse Laplace transform. So Laplace transform first. Laplace of 1, this is equals to, Laplace of 1, this is equals to just nothing but 1 by s. Okay, Laplace of 1, this is equals to 1 by s. Similarly, Laplace inverse of 1 by s, just opposite, that will be 1. Okay, Laplace of t to the power n. Laplace of t to the power n, this is equals to n factorial divided by s to the power n plus 1. Similarly, if you apply Laplace inverse to both sides of this equation, so you are getting that t to the power n, this is equals to Laplace inverse of n factorial divided by s to the power n plus 1. And under Laplace inverse, you can write only the function of s. Okay, so obviously you can take this n factorial out of this Laplace inverse operator. So you can write this is equals to n factorial Laplace inverse of 1 by s to the power n plus 1. Yes or no? So you are getting Laplace inverse of 1 by s to the power n plus 1. This is equals to t to the power n divided by n factorial. Yes or no? Now I am writing this formula. So Laplace inverse 1 by s to the power n plus 1. This is equals to t to the power n divided by n factorial. Clear? Now, similarly, using this formula, Laplace of t to the power n, we can easily find out the formula of Laplace of t. Yes or no? Laplace of t means here n equals to 1. So Laplace of t, that will be equals to n equals to 1. That means 1 by s square. Okay. Similarly here, Laplace inverse of 1 by s square, that will be equals to t. Clear? So here we have three formulas, and we can use these three formulas when the given function f of t, this is in polynomial form. Polynomial in t. Okay, so if the given function f of t, this is in polynomial form, polynomial in t, then we can use these three formulas. Actually, this is the general formula. Laplace of t to the power n, this is equals to n factorial divided by s to the power n plus 1. Now, if you put n equals to 0, you will get t to the power 0 means 1, Laplace of 1. Put n factorial, that means 0 factorial. 0 factorial means 1, and s to the power 0 plus 1, that means s. So you are getting 1 by s. Clear? Similarly, Laplace of t, that means you have to put n equals to 1. So 1 factorial, that means 1, and s to the power 1 plus 1, that means s square. Clear? So these three formulas are for polynomial. Now, formula number 4. Laplace of e to the power at. Okay, Laplace of e to the power at. Just here you have to write 1 by s minus a. If this power a, this is positive sign, then you have to take here negative sign, opposite. Okay, similarly, Laplace inverse 1 by s minus a, that will be equals to e to the power at. Okay, now Laplace of e to the power minus at. So obviously here you can see we have negative sign, so we have to take here positive. So 1 by s plus a. Similarly, Laplace inverse 1 by s plus a, this is equals to e to the power minus at. Clear? Obviously, these two formulas we can use when the given function f of t is in exponential form. Exponential form. Clear? So first three formulas when f of t is polynomial form. Now fourth and fifth formulas are when f of t is in exponential form. Now number 6. Number 6, let's say trigonometric form. So Laplace of sine at. This is equals to, when the trigonometric function is sine, the numerator will be constant number a divided by s square plus s square. Okay, when the trigonometric function is sine function, the numerator will be a and the denominator will be s square plus s square. Similarly, Laplace of cos at, when it is cos, you have to take the numerator, the function s function. This is not constant number, s is variable. Okay, divided by s square plus s square. Clear? Similarly, in formula number 6, if you apply Laplace inverse to both sides of the formulas, so you will get Laplace inverse of 1 by s square plus s square. This is equals to sine at divided by a. Yes or no? If I apply Laplace inverse, this a, that will be out of the operator, so I am dividing by a. Similarly here, Laplace inverse s by s square plus s square, this is equals to, that will be cos of at. Okay, Now, these two formulas when f of t is in trigonometric form. Trigonometric form. Okay. Now, number 8. Laplace of sine hyperbolic at. When it is hyperbolic function, formula is almost same. The numerator will be same constant number a, but the denominator, here the denominator is s square plus s square. But in hyperbolic function, that will be s square minus s square. Okay. Similarly, Laplace of cos hyperbolic at, that is equals to s by s square minus s square. Similarly, here Laplace inverse 1 by s square minus s square, this is equals to sine hyperbolic at divided by a. Similarly, here Laplace inverse s by s square minus s square, this is equals to cos hyperbolic at. And these two formulas are for hyperbolic function. Okay. Now let me summarize the full 9 formulas. First 3 formulas for polynomial, next 2 formulas for exponential, then next 2 formulas for trigonometric, then 2 formulas for hyperbolic. Okay. Just you have to remember the second formula in polynomial case. Laplace of t to the power n, when the power is n, the result will be n factorial, and the power of s, that will be increased by 1. So n factorial divided by s to the power n plus 1. Now Laplace of 1, that means you have to put n equals to 0. Laplace of t, that means you have to put n equals to 1. Actually, these two formulas, formula number 1 and formula number 2, formula number 3, we are getting these two formulas from formula number 2. But I have written because these two formulas, we can use these two formulas in many problems. Okay. Now, formula number 4. Laplace of e to the power at. When the power of exponential is positive number, just you have to change the sign. That will be 1 by s minus a. And Laplace of e to the power minus at, that will be 1 by s plus a. Okay. Now for trigonometric case, if the function is sine, then the numerator will be constant number. If function is cos, the numerator will be the variable s. Okay. And for trigonometric case, the denominator will be plus sign, s square plus s square. And for hyperbolic, similarly for sine hyperbolic, numerator will be constant number, and for cos hyperbolic, numerator will be variable s, and the denominator, that will be negative sign, s square minus s square. Okay. If you can find out all the formulas of Laplace transform, then easily you can find out all the formulas of inverse Laplace transform. So I will advise you not to remember all these formulas of inverse Laplace transform. Just remember the formulas of Laplace transform, and easily you can get the formulas of inverse Laplace transform. Okay. Now we have to prove these formulas. But all these formulas, the proof of all these formulas are not important for your examination. Just I will solve some specific proofs. Okay. So next, I will solve formula number 4. Number 4. Formula number 4 is Laplace of e to the power at. This is equals to 1 by s minus m. We have to prove this. Okay. Actually, here what is f of t? Here f of t equals to e to the power at. Yes or no? Now you can use the definition of Laplace transform. Definition of Laplace transform is Laplace of f of t. This is equals to integration 0 to infinity e to the power minus st ft dt. This is the definition. So here ft equals to e to the power at. So Laplace of e to the power at, this is equals to integration 0 to infinity e to the power minus st into e to the power at dt. Okay, so you are getting integration. Acha, this is improper integral, and we know how to solve improper integral. Here in upper limit you are getting infinity, infinity, so you have to put in place of infinity capital X, and then limit capital X tends to infinity, and this is e to the power a minus s into t dt. Okay, just solve this. So this is equals to limit x tends to infinity, so you are getting e to the power, integration is with respect to t, na? So this will be e to the power a minus s into t divided by a minus s, 0 to capital X. Okay, if you put upper limit, so this is equals to limit capital X tends to infinity, so e to the power, acha, 1 by a minus s, this is common, 1 by a minus s, so you are getting e to the power a minus s into capital X upper limit minus lower limit. Lower limit means you have to put t equals to 0, so you will get e to the power 0. E to the power 0 means 1. Okay, now x tends to infinity. When x tends to infinity, actually here this is e to the power a minus s into x, so you can write in this form that limit x tends to infinity 1 by a minus s into e to the power minus s minus a into x. Yes or no? Just I have taken minus common, minus 1. Clear? Now put limit x tends to infinity. So 1 by a minus s into e to the power x tends to infinity, that means e to the power minus infinity. And what is the value of e to the power minus infinity? 0. Okay, that means you are getting 0 minus 1. So the final result is minus 1 by a minus s. That means this is equals to 1 by s minus a. Hence proved. This is our proof. Yes or no? Just you have to use the definition of Laplace transform. Clear? Similarly, you can put the formula number 5. That means Laplace of e to the power minus at. Just here you have to take ft equals to e to the power minus at. Okay, you will get here e to the power minus at, and that will be minus a plus st. Okay, let's try when f of t is e to the power minus at. Try it. Okay, I am solving the next theorem, that means formula number 6. Sixth formula is Laplace of sine at. This is equals to a by s square plus s square. Okay, we have to prove it. So proof. Obviously here f of t equals to sine at. Before that, tell me what is the expansion of e to the power I theta. What is e to the power I theta? We know that e to the power I theta equals to cos theta plus I sine theta. Yes or no? Here you have at. So I am writing e to the power I at. What is e to the power I at? Obviously, you have to put theta equals to at. So you are getting cos at plus I sine at. Now apply Laplace to both sides of this. Let's say this is equation number 1. Okay, so Laplace of e to the power I at. What is Laplace of e to the power I at? You know, 1 by s minus ia. Just I have proved the formula number 3. Sorry, formula number 4. Laplace of e to the power iat, this is equals to 1 by s minus ia, because here a equals to I. And Laplace of iat, so you can write in place of e to the power iat, you can write Laplace of cos of at plus I sine at. This is equals to, this is 1 by s minus ia. So you can simplify this in this form. s minus ia. Let's multiply both numerator and denominator by the conjugate, complex conjugate, s plus ia. So from the right hand side, you are getting s plus ia divided by, so what is the denominator? This is a plus b into a minus b form. So you are getting s square plus s square. Yes or no? Actually, you are getting s square minus ia whole square. So this is equals to s square minus I square means minus, that will be minus square. That means you are getting s square plus s square. Clear? So s plus ia divided by s square plus s square. Now, if I simplify this, let's break this form into two parts, real part and imaginary part. So this is equals to s by s square plus s square plus, and the imaginary part is I into a by s square plus s square. Clear? Now from the left hand side, you can see, you can break this left hand side in this form, the Laplace of cos at plus I into Laplace of sin at. Okay, and this is equals to nothing but s by s square plus s square plus I into a by s square plus s square. Our condition is, or our question is, just you need to find out, or you need to prove the formula Laplace of sin at. But here I already have proved the Laplace of cos at as well as sin at. If you compare both real and imaginary part, comparing both real and imaginary parts. So what are you getting? So Laplace of cos at, this is equals to, this is the real part. So you are getting s by s square plus s square, and Laplace of sin at, this is equals to a by s square plus s square. Clear? Okay, so in a single proof I have proved two formulas, Laplace of sin at and Laplace of cos at. Okay, and this proof is important for your semester examination. Okay, now next proof the formulas for the hyperbolic function. Okay, so next formula number 7 7 formula number, sorry, 8, formula number 8. The question is, you have to prove Laplace of sine hyperbolic at. This is equals to a by s square minus s square. Okay, you have to prove Laplace of sine hyperbolic at. This is equals to a by s square minus s square. Remember, there is an expression sine hyperbolic theta. This is equals to e to the power theta minus e to the power minus theta divided by 2. Okay, and similarly cos hyperbolic theta, this is equals to e to the power theta plus e to the power minus theta divided by 2. Here they have asked about sine hyperbolic at. That means you have to put theta equals to at. So what is sine hyperbolic at? Hyperbolic at. So obviously you can write e to the power at minus e to the power minus at divided by 2. Yes or no? Now apply Laplace to both sides of this expression. Sine hyperbolic at, this is equals to, half is common, so half into Laplace of e to the power at minus Laplace of e to the power minus at. Okay, so this is equals to half into, what is Laplace of e to the power at? I already have proved it. So 1 by s minus a minus e to the power minus at 1 by s plus a. Just simplify this. So you are getting half into, the LCM is s plus a into s minus a, that means s square minus s square, and the numerator will be s plus a minus s plus a. So s cancelled, so you are getting half into 2a divided by s square minus s square. So 2 cancel, so this is equals to a by s square minus s square. Clear? So here I have proved Laplace of sine hyperbolic at, this is equals to a by s square minus s square. Very simple, just you have to remember these two expressions. Okay, then you have to put theta equals to at, then apply Laplace transform to both sides of the expression. Okay, similarly you can prove Laplace of cos hyperbolic at. So formula number 9, Laplace of cos hyperbolic at, and we have to prove that this is equals to s by s square minus s square. We know that cos hyperbolic theta, this is equals to e to the power theta plus e to the power minus theta divided by 2. Now apply Laplace transform. So Laplace of cos hyperbolic, sorry, you have to put theta equals to at. So Laplace of cos hyperbolic at, this is equals to e to the power at plus e to the power minus at divided by 2. Now apply Laplace. So Laplace of cos hyperbolic at, this is equals to half is out of the operator. So Laplace of e to the power at plus Laplace of e to the power minus at. So this is equals to 1 by 2 into Laplace of e to the power at is 1 by s minus a plus, similarly Laplace of e to the power minus at, that will be 1 by s plus a. So simplify this, half into the LCM will be s square minus s square, this is s plus a plus s minus a cancelled, so you are getting half into 2s divided by s square minus s square. 2 cancel, so finally you are getting s by s square minus s square. Okay, hence proved. So today in this video we have discussed what is Laplace transform, what is inverse Laplace transform. Also we have discussed 9 basic formulas of Laplace transform, and also we have proved these formulas. Okay, in my next lecture we will start some formulas of some important formulas, for example scale property, shifting property, inverse shifting property, second shifting property, etc. Before that, let's solve some problems using these 9 formulas. Okay, let's say first question. First question, find Laplace transform of sine 3t plus e to the power minus 2t. Okay, this is the question. Find Laplace transform of sine 3t plus e to the power minus 2t. Very simple. Laplace always satisfy linear property, so you can break this Laplace. So Laplace of sine 3t plus Laplace of e to the power minus 2t. Okay, this is equals to, what is Laplace of sine 3t? You know the formula, Laplace of at equals to a by s square plus s square. So this will be 3 by s square plus 3 square, that means 9, plus Laplace of e to the power minus 2t. So obviously this is negative sign, so that will be 1 by s plus a, that means s plus 2. Clear? If you want to simplify this, you will get this is equals to s plus 2 into s square plus 9. Okay, so you are getting 3 into s plus 2 plus s square plus 9. So this is equals to s square plus 3s plus 15 divided by s plus 2 into s square plus 9. Okay, very simple. Next solve another problem. Next question, find Laplace of sine 2t minus cos of 2t whole square. Laplace of sine 2t minus cos of 2t whole square. Solution. We can write, this is a minus b whole square, na? So obviously you can write sine square 2t minus 2 sine 2t cos 2t plus cos square 2t. Yes or no? This is equals to Laplace of, this is sine square theta and this is cos square theta, and you know sine square theta plus cos square theta equals to 1. So this is equals to 1 minus, and this is 2 sine theta cos theta, and 2 sine theta cos theta equals to sine 2 theta, that means sine 40. And what is Laplace of 1? Laplace of 1 equals to 1 by s minus, and what is Laplace of sine 40? 4 by s square plus 16. Okay, this is the answer. Very simple. Okay, let's try another problem. Next question. Find Laplace of sine t into cos 2t. Okay, find Laplace of sine t into cos 2t. Solution. If I multiply half, so that will be half into Laplace of 2 sine t cos 2t. Yes or no? And you know the formula 2 sine a cos b. What is the formula of 2 sine a cos b? 2 sine a cos b. This is equals to sine a plus b plus sine a minus b. Yes or no? Just apply this formula. So half into Laplace of 2 sine a cos b. So you are getting sine a plus b. That means sine t plus 2t. So sine 3t. Okay. Plus sine a minus b. That means sine t minus 2t. That means sine minus t. Okay. So you are getting half Laplace of sine 3t and sine minus t. That means minus sine t. Okay, half into what is Laplace of sine 3t? Just simple 3 by s square plus 9 minus Laplace of sine t means 1 by s square plus 1. Okay, if you want to simplify this, so half into, so this will be 3 into s square plus 1 minus s square plus 9 divided by s square plus 1 into s square plus 9. Okay, so you are getting half into, the numerator will be 2s square and plus 3 minus 9, that means minus 6 divided by s square plus 1 into s square plus 9. 2 is common and 2 cancel, so you are getting s square minus 3 divided by s square plus 1 into s square plus 9. Okay, let's solve a problem from inverse Laplace transform. So next question, find Laplace inverse of 4 by s minus 2 minus 3s by s square plus 16 plus 5 by s square plus 4. Solution. Laplace and Laplace inverse always satisfy linear property. So you can break this full expression. So Laplace inverse of 4 by s minus 2 minus 3 is out. So 3 Laplace inverse of s by s square plus 16 plus 5 is out. So 5 Laplace inverse of 1 by s square plus 4. Okay, now this is equals, here 4 is out, so 4 Laplace inverse of 1 by s minus 2. Let me write again, 4 into Laplace inverse of 1 by s minus 2 minus 3 into Laplace inverse of s by s square plus 16. Okay, plus 5 into, here you can see that denominator is s square plus 4. Yes or no? That means you can apply trigonometric formula. Yes or no? The trigonometric formula denominator is s square plus s square. Now if it is sine, then let me again. When Laplace of sine 80, the formula is a by s square plus s square, and when Laplace of cos 80, the formula is s by s square plus s square. Here s is variable, so but there is no variable s, so you cannot apply cos. Okay, from this expression you will not get cos. Obviously you will get sine, but in sine the formula is a by s square plus s square. This is a square, no? That means 2 square. So what is the value of a? Obviously 2, but formula is a by s square plus s square. So obviously you need 2 in numerator. Clear? I am repeating. For sine, here you can see s square plus 4. That means obviously you can apply trigonometric formula. Okay. For sine, the numerator will be constant number. For cosine, the numerator will be variable. But there is no variable, so obviously cosine is not possible. Okay, so obviously sine possible, but in case of sine, the numerator must be the number a. And what is the value of a in this problem? S square plus 4, that means s square plus 2 square. So a is equals to 2. So obviously in place of 1 you have to write 2. That's why I am dividing 2 and writing 2 here on numerator, s square plus 4. Clear? Now you can easily solve. This is Laplace inverse of 1 by s minus 2. This is negative sign, so this is the Laplace Laplace of e to the power 2t. So that will be 4 e to the power 2t. Clear? Minus 3 into, this is s by s square plus 16. 16 means 4 square. So this is 3 into cos 40, and this is plus 5 by 2 sine of 2t. This is the answer. Okay, very simple. Let's solve another problem. Find Laplace of root over 1 plus sine t. Laplace of root over 1 plus sine t. So you can write, this is 1 plus sine t, no? So you can write in this form, 1 is equals to sine square t by 2 plus cos square t by 2 plus, this is sine t. We can write sine t in this form, 2 sine t by 2 cos t by 2, sine 2 theta formula. Okay, so this is equals to, this is a square plus b square plus 2ab, that means a plus b whole square. So Laplace of, you are getting sine t by 2 plus cos t by 2 whole square. So this is equals to Laplace of sine t by 2 plus cos t by 2. By linear property, you can write Laplace of sine t by 2 plus Laplace of cos t by 2. Okay, and what is the formula of sine 80? Here a is equals to half, na? So you will get half by s square plus 1 by 4. Similarly, here a is equals to half, so s by s square plus 1 by 4. If you want to simplify this, so you will get this is 2 by, this will be 4s square plus 1 plus, from here you will get 4s divided by 4s square plus 1. Okay, so after simplifying this, you are getting 2 into 1 plus 2s divided by 4s square plus 1. This is the final answer. Okay, I think the basic concept of Laplace and inverse Laplace is now clear. Now you can try your textbook problems. Okay, thank you so much.